Hi everybody, this is Mr. B from Hayfield Secondary School. I am the middle school engineering teacher, and this video is about engineering your glider in the Whitebox learning application. I am going to walk you through and show you exactly how to get just kind of a base design working, and let's just get started. This video does assume that the student has already completed the research section. If they have not completed the research section, you need to do that because you need to understand the terminology and the components and the interaction of the components of a glider before you try to design one. All right, so it does assume that students have completed the research section. Let's jump right into engineering. All right, so we're going to start with a new design. Remember, Whitebox is pretty good about and giving you a starting point. And that's it. I'm just going to call it something really kind of boring. Oh, I already have one called that. Mr. B's. So it's just a basic glider. All right, there we go. Okay, so what does it look like, the default glider? As you know, Whitebox gives you a default design. Click on all the little view symbols except for this one that says design model. That one just gets annoying and in the way, okay? There you go. That's what it gives you. Now, is this glider any good? Are Whitebox design, base designs that they give you, are they usually any good? No, they're not, okay? So, well, just how not good is this thing? Well, this is a really great little bunch of analysis features down here, but I tell you what, here's the one that you're going to just really use as your scorecard, okay? This is an optimization window. Very easy to interpret. This gives you a score for all these different aspects of your glider, the weight, the lift, the drag, so on and so forth. And you want all these indicators to be as high up in the green section as possible. Any indicator that is down in the red unstable part means your glider's not going to fly very well at all. Flying machines are different than perhaps like, you know, a vehicle, a mousetrap car, a glider, or things like that. Everything on a flying machine has to be working well in order for the machine to fly well. So you can't get away with anything down in the unstable section, okay? Everything works together. And you're going to see as we go through that, we're going to change one thing, it's going to affect something else a lot more than you might have thought. But that's okay. And Whitebox has ordered this stuff really nicely, is that we can just kind of go top down to bottom. And our goal is, objective is to get all these indicators high up in the green section of this, all right? So let's start with the fuselage. If you recall, from the research section, the fuselage is the main body of the plane. When you fly an airplane, you are sitting in the fuselage, okay? And of course, the wing and then the vertical and horizontal stabilizers in the back. So let's look at the fuselage. It's very nondescript right now. It's just rectangular and hasn't been, you know, tapered to be aerodynamic or kind of to look airplane-ish at all. Also, let's go ahead and look at our outputs right now too and say, are we in spec? No, we're not. We're not way out of spec, but we're talking about the fuselage right now. So right at the top, it just tells us our fuselage is a little bit too long. We're at 302, the max can be 300. We can be between 275 and 300. Okay, so let's just worry about the fuselage right now. So here we go. There's the length of fuselage. I just make it shorter. I'm going to do 290. All right. Just gets us in spec. Whoop, hold on. Gets us in spec, and we can move on. All right. Now our weight score is not that great. It's okay, but let's see if we can. How do we make the weight of something less? Let's be honest. The simple way to do it. We can change the materials, but that's not an option here. This is a balsa glider, and that's what we're building with. So, if we make something bigger, is it going to weigh less? No, we know it's not. Okay, so we need to make something smaller. So we can make things smaller by making them shorter. So what if I take this down to the minimum 275 that we're allowed to do? We'll might see a small change. Yeah, it didn't hardly affect it at all. But tapering the nose, what does taper mean? So see how now it's just a blunt rectangular nose? I haven't seen many airplanes that look like that. I click tapered nose, so it's got a pointy, it's more aerodynamic, it's going to weigh a little bit less as well. Also, the body of an airplane, if you look at the body of an airplane, it's not all rectangular, it's also kind of tapered as well. So we're going to pretty much taper everything along here, okay? Looking a little bit more like an airplane as we taper things. All right, so we've got everything tapered that we can taper, and the weight score is not terrible. Ballast, let's talk about ballast a little bit. Okay, so ballast is weight that is added to a machine, flying machine, or boats, added to sailboats in particular, to help with overall stability. Like in a sailboat, you have to put a lot of weight way down, as far down in the boat as possible, to make it more stable, keep it from tipping over as easily. And they defaulted the ballast to 1 gram. Okay, I don't know. Let's kind of reduce that because I don't know how much ballast we're going to need now, and that just made our weight a lot better. 1 gram is actually in the world of balsa gliders, that's actually a fair amount of weight. So you probably need some. That's going to be in the nose of the airplane, and so that reduced our weight a little bit. And we're not going to add anything to the back, so we shorten the plane to be as short as possibly can. We've tapered the nose and the overall body of the plane, and we've reduced our ballast a little bit, so our weight score is now pretty good. All right. So lift, okay, what is the component responsible for lift on an airplane? There's really just one, all right, that responsible for the vast majority. So if we go back over to research, if you want to just refresh your memory a little bit, I highly recommend that. It's the wing, okay? The wing is where your lift is coming from. And the way it works is wings on modern airplanes are shaped like this. This is an airfoil shape. It looks kind of like, I call it a tadpole. If you've ever seen tadpoles, they look just like this from the side, but it's kind of like an elongated teardrop. The front, notice, is rounded off. The bottom is relatively flat, and the top kind of curves up higher than the bottom. Is not nearly as flat as the bottom. What happens is, as the air flows around this airfoil shape, the air over top of it passes over much faster, okay, than the air underneath of it. And the air underneath of it, it creates a high pressure. So it's low velocity, high pressure air. So there's more pressure underneath, less pressure on top. So if you're pushing underneath of the wing more than the forces pushing down on the wing, you're going to lift it up. Like any object, if you lift it up, push it from the bottom, it's going to go up, right? So that's the airfoil shape. So it's the wing. And there are different ways to calculate the efficiency of the wing, and they get into that. We'll talk about that later. This is when we're really trying to optimization, okay? And there's a thing called lift efficiency ratio, engineering tip. Like I said, we'll get into that a little bit later, but what it has to do with the size of the wing as compared to the overall weight of the glider, okay? So let's get back to the wing over in engineering. okay? We have this very boring rectangular wing right here. So let's go to the wing section right here. All right, that's what we got, okay? Let's just try changing the size of the wing. Simple rule, the bigger the wing, the more lift it's going to create. So I'm just going to make this wing a whole lot bigger, like way bigger. Lift goes way, 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 way up. Some other things changed too, but also what happened to the weight. The weight got a lot worse because a bigger wing weighs more than a smaller wing, right? So probably don't want to go that big. We got pretty good lift there. So we can just, using this CAD-like program here, we can try some different shapes. We do want to get a lift score, but we don't want to make the plane too overall heavy as well. Now, if let's scroll down here a little bit. I'm going to close this window for right now. We're focusing just on the wing. We can do the shape geometrically two ways. We can do the shape with all straight lines, or we can do curved lines. And if we go back over here and look at wings, you're not going to see many airplane wings that are nothing but straight lines, all right? They all have curvature to them. I'm really going to recommend you go ahead and do a wing that takes advantage of this curved geometry. It lets you build a wing that is more realistic. It's also going to be more aerodynamic. We'll talk about that in a second, okay? So our drag got a whole lot better simply because the front edge is curved. We'll talk more about that in a little bit. Now let me try to start making my wing a little bit bigger and a little bit different shape and see if I can get my lift to go up. My lift is going up quite a bit, and you can just experiment with different shapes and curvatures and get to where you have a wing that has pretty good lift and your weight is still, relatively high score as well. So I just did that quickly. You can experiment on your own to get something that has good lift and doesn't sacrifice too much on your weight score. I'm going to make the wing a little bit wider because periodically we want to come over here, check our outputs, and make sure everything is in spec. All right, everything is still in spec. So I'm getting a pretty decent scorecard on this, and I'm still in spec. So let's move on. All right. So next one is drag. Well, our drag is excellent, okay? But let's go ahead and do a quick review of that as well, okay? Just switching to that round geometry, getting away from this nothing but straight lines of our wing, these curved lines here, dramatically improved our drag because smooth surfaces allow air to flow more naturally and faster, creating less drag. So just by going with the curved edges, that really helped a lot. Something really interesting, though, happens at the tip of the wings, okay? At the tip of the wings, there's this thing talked about called induced drag. So at the very tip of the wings, you can create a lot of drag there. It's called induced drag. In other words, your design is inducing this drag as the air flows over the wings. And it says a technique used to, engineering tip, a technique used to reduce induced drag is to taper around the edges of the wing tip, okay? So when we decided to use this rounded geometry, it improved a lot of things, and we didn't even expect that, okay? And again, we can do some more things, as experiment with some more things, more curves, and see, how it helps us out, okay? And this is very experimental, okay? Trial and error. That wing looks kind of cool. It kind of looks like a bat wing, I guess. I like bats. So there we go. Let's move on. So we got some good scores. Our next one to look at is roll. So what is roll? All right, back to the section. They'll give you a nice little description. Roll is the tendency of our plane wingtip to wingtip to kind of roll to the left or roll to the right and not fly straight and level, okay? And that is something that we need to control. If your plane is unstable and rolls to the left or roll to the right really easily, it's very hard to control that plane. Well, they came up with a simple way in designing your plane is just angling the wings up a little bit. And that's what we're going to do. And wings on an airplane are not completely flat. Okay, they don't just come straight up from the fuselage. You might think they do, but if you look at them, if you're able to look straight onto your airplane like this view here is, you will see, and I'm going to do that here. Let me try to look at it straight on. Ours are angled up a little bit. See how they're angled up a little bit here? They are not flat. I'm going to go ahead and set that angle to 0 to show you what flat looks like. Okay, that's flat. Boom. And notice what happened to my roll when that happened. My roll tanked, okay? It got really bad. No planes have flat wings like that. Maybe some of the real old ones did because they hadn't figured this out yet. But, okay, so let's put it back. I think it would default it to 5 degrees, okay? Angle them up a little bit, looking straight on. My roll score got better, but still not so great, right? So let's go back here. They tell us exactly what to do, which is really, really nice, okay? And there are different styles of wings. Some are angled all the way from the fuselage out. Some are flat and then only angle up at the tip. And then this one is called tip dihedral. And the other one is called a poly. Poly just means many. And so poly is got a little bit of angle and then even more angle at the tip. We're going to keep it simple right now. We're just going to stick with the straight dihedral, okay? And it is going to help us as your plane has a tendency to want to try to roll to the left or roll to the right. That angle really helps us out and keeps us more stable. And they have a little interactive, kind of interactive little function here for us to look at and help us out a lot. So here is flat wing. And we did that, right? We went over here, we went flat wing, and our roll score tanked. It was terrible. So they're going to say, okay, 0 is not good. 0 really messes you up. So what happens if we increase the angle of our wings to our, it says here, incremental flight time, that y-axis right there, that means how much improvement does it do to how far our plane flies. And so if I just click next, it says, okay, if we angle the wings a little bit, we get an improvement. And this here looks like they angled it. I'm going to guesstimate. It's almost 10, more than 5, and so like maybe 8 degrees. So let's pop over here real quick. And let's set that angle to 8 degrees. It defaulted to 5. I'm going to set it to 8. Boom. Our roll improved, okay? Still's got a way to go. Let's go back over and see what research tells us. Got to go back here. Okay, so we know what 5 did. That was default. Then we kicked it up to 8 based on this. Well, let's see what else they tell us. Well, they increased it again. They went up to, looks like right smack dab between 15, between 10 and 20. Which would be 15, it increased quite a bit more. So adds 3 seconds to our flight time, which means it's helping with stability a lot. What if we increase it even more? Oops, and it gets worse. And gets worse again. So what is the optimum angle that we want to use according to this chart? Well, there's our highest point on the chart. It adds 3 seconds to our flight time, which is a lot. And if we come down to the x-axis, it's right between 10 and 20, which we are going to say is 15. All right, let's check it out. We're going to come over here, and we're going to say 15. Boom. Okay, that's about as good as our roll score can get. Okay, so right here you can see our wings are angled up at 15 degrees. And our roll is maxed out to the best setting it can be. We're pretty happy about that, right? So we're done with roll. Nothing else to do here. Let's go on to pitch, okay? Well, pitch. What is pitch? Just remind ourselves, hop over to the research section. Pitch is the tendency of our nose to either want to go down or go up, okay? Well, what we really want is a plane that wants to naturally fly just straight and level. We don't want it going down towards the ground. We don't want it going straight up either, because it'll do this thing called stalling. In other words, not enough power for it to go up, and then it kind of flutters to the ground like a leaf falling off a tree. So we want it to naturally want to fly straight and level, okay? That is pitch, pitching down or pitching up, okay? And it has everything to do with the center of the gravity of your glider, okay? So it's where we get the center of gravity is going to control the pitch. If our center of gravity is way, way, way up towards the nose, it's going to pitch straight down, okay? If it's way, way too far back to the tail, the tail's gonna want to go down, which means our nose is going to go straight up. So there's a magic sweet spot right in there somewhere, and we just have to find it, okay? So let's go back over here. Now remember, what is center of gravity? Okay, center of gravity is where the point at which the mass, or the weight, I should say, not the mass, the weight on either side of the center of gravity is equal. So this blue spot right here means that to the left here, this weight is equal to the weight to the right. That's the balancing point. The balancing point and center of gravity are the same thing, okay? So where do we want that balancing point to be? Now, you see the wing right here? If we were to move the wing backwards towards the tail, would that change the center of gravity? Yeah, it probably would because the wing is pretty big. The wing weighs quite a bit as compared to everything else on here. So let's take a look at that. So on our design right now, our wing is pretty far forward, and it's telling us our center of gravity is not so great. So if we had to guess, would we say the center of gravity is pretty far forward on this plane, or it's too far towards the back? Well, we don't have to guess. This is Whitebox after all. So if I click on pitch, it's going to show me where the center of gravity is. And it showed me here, right? It puts a little indicator right there and saying your center of gravity is pretty far forward on the plane. So how can we move it back a little bit? Not a whole lot. We don't want it all the way back here, but how can we move it back a little bit to kind of balance things out? Okay, so if we look at that, we're on the wing because we're going to be moving this wing around because that's a lot of weight to the overall weight of the glider. It says the offset. This offset, they're meaning from the nose of the airplane, right here, the very nose, okay? From the nose of the airplane to the front of the wing, it says is 30 millimeters, all right? So if we want to push this wing back a little bit to move our center of gravity back a little bit, we're just going to change this number a little bit. Again, we don't want to make huge changes. We want to sneak up on a good design. So I changed it to 40. Wing moves back. If you notice, center of gravity improved a little bit, but we could probably do better. I'm going to go to 50 millimeters or 5 centimeters. Improved a little bit more. So let's kind of sneak up on it here a little bit. 60. And I am probably going to stop here because we're not done making changes yet. All right, so pretty good. We got a pretty good score there. The wing has been moved back. And if we look at, modern airplanes, you're going to see the wings are not, just point of reference, okay? The wings are not like all the way, where was the one? Was it, it was drag. Had a picture of a real airplane. Like this, you can see the wings are not all towards the nose of the airplane. They're kind of back, okay? Now, we got big engines and everything, so the rules are kind of different on a powered airplane, but you can still take that as a decent example. The wings aren't all the way up towards the nose, okay? They're kind of centered back towards the center of the plane. So our pitch got pretty good. So let's do a quick review here before we move forward, okay? Our weight is okay. We'll talk more about that in a little bit. Lift is pretty good. Drag and roll are excellent. Our pitch is pretty good, meaning our plane does not have a great tendency to either want to fly straight down in the ground or straight up in the air. And so now we want to move on to, is this guy in your way? Kind of, okay, let me move it out of the way so we can see a little better. Is another part of pitch is controlled by this horizontal stabilizer. That is this guy in the back I mentioned earlier, okay? Looks like a little wing back here, right? Yeah, no, it looks like it, but it's not. It's a horizontal stabilizer, which means it also controls the tendency of the tail wanting to go up or wanting to go down, okay? And so the size of this horizontal stabilizer, size and shape, interacts also with the wing and helps with the control the pitch. So there's actually three things. There's your center of gravity, and this pitch neutral point, don't worry about that right now, but also the horizontal stabilizer. Pitch is pretty darn important, okay? So let's go take a look at our horizontal stabilizer. It happens to be next thing on the list. Whitebox is really good about doing that, okay? And there it is. We can change the design on it, okay? Well, let's change the shape of it and see what it does with our overall score. I can't move that anywhere. Yeah, good. I'm moving that out of the way. That's better. Okay. So I can change this horizontal stabilizer. And again, I can do curved, straight lines. I'm going to go curved. We had good luck with curved on the front wing. Come on, Whitebox. All right, there we go. All right. So just doing that made things horrible. So what if I make my horizontal stabilizer a little bit bigger? That didn't really, it made things terrible. Made things terrible. Also messed up my center of gravity. That kind of makes sense, right? I just made another part of the plane bigger, so it's heavier. So now the distribution of weight on the plane just changed. I want to go back to where I was. But instead of making it bigger, maybe you ought to think about making this thing smaller, right? Okay. That's getting me kind of where I want to be. Make it a little bit smaller. Does that improve it? And there we go. I'm going to stop there. Okay. Again, I noticed that making it bigger made things a lot worse. So if bigger made it worse, maybe smaller make it better. I do like using the curved geometry when we're designing these things because it does reduce drag. Curved lines just have less drag than straight lines. Angles, I should say. Right angles, we don't like right angles in airplanes. You don't see them on airplanes. So we're getting a pretty good scorecard here, right, overall. Now, yaw, that's a funny word. I kind of like that word. What is yaw? Well, it's really best just to go and look at these diagrams. Here, what yaw is what controls your plane to want it to fly straight, okay? Roll, is it rolling from left to right? The wings going left and right, okay? Pitch is the nose down or nose up, but yaw is it wanting to fly straight, the direction that you're pointing the plane. You want it to fly in that direction, okay? And that is controlled mostly by this vertical stabilizer, okay? And planes, there is a relationship between these two stabilizers in the back. Remember, we call this the horizontal stable and vertical stabilizer. There is a relationship. Here's a good, remember these engineering tips, very helpful. This is a good rule of thumb. It's when you're designing that vertical stabilizer, it should be about 1/3 to 1/2 the size of the horizontal stabilizer. Remember I said in the beginning, everything kind of plays with everything else. Everything influences something else. And so they're telling us there is a relationship between the vertical and the horizontal stabilizer. So we want our vertical stabilizer to be about 1/3 to 1/2 the size of the horizontal stabilizer. Let's see what that looks like. All right. So we come over here and we're going to go to our vertical stabilizer. Just click on the toolbar. All right. And let's go ahead and turn this on too. All right. So right now it is telling us, see this right here? It was talking about the vertical and the horizontal stabilizer. We want them to be between 1/3, the ratio between the size of them, between 1/3 to 1/2. And so by turning on this yaw right here, because that's what we're working on, yaw, in other words, flying straight, it tells us that relationship is 0.25 or 1/4, so it's too small. So that tells me that we need to make this bigger because this relationship is the size of the vertical divided by the size of the horizontal. So if we want that to be a bigger number, we need to make the vertical bigger. So I'm just going to make it a little bit bigger. It went up to 0.38, which is more than 1/3. 1/3 would be 0.33. 1/2 would be 0.50. Okay. And that's what we're going for. And notice that yaw number got much, much, much better. I'm just going to make it a little bit bigger. Can I make it even better? And now it's like really good. I'm stopping. Okay. This is telling me I have a pretty good airplane. Most categories are pretty good. Center of gravity got off a little bit because when I changed the size and shape of the stabilizers in the back, okay, I changed the weight of the back, which means my center of gravity kind of moved a little bit because everything's related, right? Everything's related. But I'm going to go with that. So we're going to go ahead and save this. And I'm going to save. I'm going to go straight to competition. This is my first rev. Let's go compete. Oh, let's check our outputs. Are we in spec? Yes, we are. That's good. All right. So let's go to competition. I'm going to compete against myself. And let's start the competition. And off they go. Now they're identical because I'm competing against myself. And let's see what the stats tell us when it's all over. Okay, told me my plane flew for 6.42 seconds. Not too bad. And it's telling me my overall mass of the plane is 7.22. We know our mass is not as good as we want it to be. Our dihedral angle, we know that 15 is the way we want to go. And then there's other stuff on here. So okay, oh, it's not too bad. Let's go back to engineering. Now that we have a pretty good plane, let's try to make it better. All right, that's the way this game works, right? So now let's go back and talk about weight for a second. All right, what is one component on here that contributes to the majority of the weight of this glider design? What's the biggest component on here? I'm hoping you say the wing, okay? The wing's huge compared to the rest of this glider, okay? Which is normal for gliders. Gliders need big, really big wings for a lot of lift because they don't have engines. So let's take a look at this wing, okay? Now, I could try some different designs with the wing, but there's something I want to call your attention to. They talk about sanding right here. Sanding level is light. In other words, this was barely sanded at all. All right? Let's talk about that a little bit. Going back over to lift. Because the more lift we have, the longer this plane should fly. Well, if you look at the edges on an airfoil, okay, notice how the nose of this airfoil is rounded over, okay, and then it's tapered down as it goes to the back. Well, our balsa wood is just a rectangle, all right? And so we would want to sand the nose of the leading edge of the wing to round it off, and we'd want to sand the trailing edge of the wing to kind of bring it to a point so that the air going over the wing is going as fast as we can get it to go, and the wing and the air underneath is going a little bit slower. So notice the bottom is pretty flat, okay? Doesn't require much sanding there at all. But the top is rounded off and then brought down to a taper at the edge. Well, we don't have quite that level of control, but we do know it's going to take more than just a real quick sanding. We're going to want to increase our sanding to at least do a medium amount of sanding. Let's see what happens. Come on, Whitebox. Everything got better. Why? Well, our plane got lighter. Notice how our weight score improved? Makes sense. When you sand a piece of wood, that sawdust that comes off of the wood weighs something, so the wood weighs less. And our edges now are curved. And so we would hope that when we sanded, we paid attention to this airfoil shape that we were trying to get with a rounded nose and a rounded leading edge and a tapered trailing edge. And so that would reduce our drag and increase our lift a little bit. So we reduced our weight, which raised our weight score, and we increased our lift. What if I said, no, we're going to sand a lot. We're really going to try to get that airfoil shape and make everything as smooth as possible. All right, our weight improved a little bit. Our lift stayed about the same, but we increased our numbers. Our scorecard, our overall optimization scorecard looks pretty good. I want to go compete this, put this in the competition. I'm saving entering competition. Let's go see what happens. Reset simulation, compete against myself. Go. 6.1 seconds last time. I know this video is getting pretty long. This will be a multiple day video for you to watch, or if you're watching at home, you can. But this is a soup to nuts video, okay? Looks a little better, kind of hard to tell. Let's see what the stats are. Okay. Our flight time went to almost 8 seconds. We were at 6.1 before. That's a pretty big improvement. Notice what happened to our mass. We went from 7 grams down to 5 grams. All right. So we got a pretty good plane here. Oh, it says out of spec. Darn it. What happened? Let's go look at outputs. How did we get out of spec? Oh, it got too light. All right, we can fix that. So we got to go make something a little bit bigger. That's kind of good. What would you make bigger if you don't have to worry about weight, right? We got to get a little bit heavier. According to these outputs, we're too light. What would you want to make bigger? Since all of these are pretty maxed out, I'm thinking I want to make my lift, improve my lift. How am I going to improve my lift? What's the one thing on here that creates lift on this plane? Well, it's the wing. So what if I just make my wing a tad bigger? Didn't see it increase. Oh, it did increase the lift. Now it did mess up my horizontal stabilizer a little bit, okay? So remember, you change one thing, it messes with something else. It messed around with the center of gravity. Let's go fix that horizontal stabilizer. You get the idea in a second. You change one thing, it kind of messes up something else. And so let's make the horizontal stabilizer just a little bit bigger. Center of gravity, you get the idea. We're going to have to be messing around with this stuff. And I'm going to stop in just a second. Ooh. Okay. Are we in spec? Wings are too long, a tiny little bit too long. I'm still a little bit too light. Oh, you know what? Remember how I got rid of the ballast? What if we add just a little ballast? You get the idea. I'm seriously going to stop now. Okay. Should be in spec now. Yeah. So I would go back here. I would save this. I would enter competition again and see how we do. All right. You get the idea. So I just want to review. All right. We did file, new. We got a pretty, let me make sure I save this one before I do anything else. We got a pretty bare bones design, new design, bare bones. And it looks like this. All right. We bring up our scorecard. It tells us it's not very good. All right. So we just start at the top and we start working our way down. Okay. I know I need to make it smaller, shorter anyway, because remember it was too long. Default length was too long. Oh. Oh, went way too long. I didn't mean to do it. Oops. Was it 285? That's what I meant to type in. All right. And then lift is our next deal, and that is the wing design. That's the default wing design. Not such a great design. Remember, I said use the curved design lines. All right. Because airplane wings are curved, and so on and so forth. And so I just worked my way down this list. Now remember, don't get frustrated. If you're fixing something down here and you see it makes something up top get worse, everything is related, all right? The wings have to play nicely with the tail, okay? With the stabilizer, shouldn't have said tail. The wings have to play nicely with the horizontal stabilizer. There's a relationship between the vertical stabilizer and the horizontal stabilizer, okay? You know, we want to taper our plane because that's, well, quite frankly, that's how planes are designed. They're pretty aerodynamic, right? They're not flying bricks. And we just work our way through it. So get to where you have a pretty good design. All your scores are up here. Save it, compete, come back, and just make small little incremental changes. All right? So I hope this was helpful for you. I'm not going to give you the magic answer because I never do. And so you can start playing around and how you can come up with the best glider possible. Don't be afraid to experiment. You can always put things back. And all these things are interrelated. And I hope this was really helpful to you. I know it's a long video, but you'll just take going through it a little bit, one step at a time, okay? But you can do this. It's a lot of fun too, all right? So that's it for now, and wish you good luck on this. It's a lot of fun.